Okay, welcome back, welcome back, welcome back. We are finding zeros of a function and continuing. I like showing you different ways to factor. Here we're going to factor using the quadratic formula. And your answer, when you finish, you will have the two answers to the zeros of the function. Okay, because it's going to be set equal to 0. I will show you that the last step for this particular last video for this particular example 1. All right, so this is the standard form to an equation. A times x to the second power plus b times x to the invisible first power equals c. So this is just standard form. And the a, the b, and the c represent a real number. And it has to be in equal 0 form in order for you to use this quadratic formula. So if you have a value here, let's say this negative 12 was to the right of the equal sign, which would make it a positive 12. Well, you have to move it to the left side of the equal sign, which means do the opposite. Opposite of a plus 12 would give you a negative 12 value, right? So that C value is now to the left side of the equal sign. You have to have it in this type of a form, right? But standard form gives us what the values are for A, B, and C in order to use that quadratic formula. So here my A value is a invisible 1, right? If you're not familiar with invisible ones, please check out my videos. I talk in depthly about invisible ones. It helps to clarify. I use a dot, 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 but you can just write a solid 1 here if you like. The B value in front of this X value is a negative 1. So that's a negative invisible 1. It's just a negative 1. And then my C value on the left side of the equal sign is a negative 12. Remember, it has to be in this form, equal to 0, in order for you to use this quadratic formula. So you have to move a value to the left side of that equal sign if it happens to be on the right. So I'm just going to organize my values for this quadratic formula because each of these letters is in the formula. And I just want to organize my work. So my A value is 1, my B value is a negative 1, and my C value is a negative 12. That's my C value here. And I'm going to label these guys, and I'm just going to start substituting them into the formula. Right? And here's the formula. So everywhere you see A in the formula, you're going to substitute a 1. Everywhere you see B in the formula, you're going to substitute a negative 1. And everywhere you see C in the formula, you're going to place that negative 12. Now I'm going to show you what that looks like here. Okay. So A equals 1. I put a 1 here for the A values, as you can see here. B equals a negative 1. I'm going to place a negative 1 for those B values into the formula. Remember that negative B is part of that formula. You have to keep that negative on the outside. And anytime you have a radical, it's always plus or minus. And so anywhere you see a C value, I'm going to put that negative 12 value you see here. Okay, now I'm going to simplify following the order of operations. And so if I'm going too fast, please stop, rewind, pause the video. And so we will follow order of operations. And what you need to know, parentheses. You're going to treat this radical as if it was a parenthesis, right? So everything underneath the radical, you're going to simplify first. And again, we follow inside under the radical, you're going to follow the order of operations. So do I have any parentheses here? I do, but they're only for organizational purposes. There's nothing inside the parentheses I can do. So then you're going to follow the next step. Exponents. Do I have any exponents here? Yes, I have an exponent. Negative 1 to the second power means negative 1 times negative 1. Negative times a negative gives me a positive. 1 times 1 is 1. And then everything else, negative 4, the 1, the negative 12, the radical, the plus and minus, negative 1, a negative outside the parentheses for negative 1, the divisor bar, 2 times the quantity of 1. Everything I'm going to rewrite. I'm only going to do the step by step, and whatever I don't simplify, I just rewrite into the next step. So let's go ahead and take a look at this next step. I've just rewritten this here for you to see. Let me move that up a little bit here so you can see it. So I just rewrote that last step. So I'm going to ask myself, focusing inside the radical because that's considered a parenthesis. Are there any parentheses in here I can simplify? No. Any exponents? No. Can I multiply or divide? Yes. -4 times 1 is -4. And then I'm going to take that -4 and multiply times this term, -12. -4 times 1 is -4 times -12 is a positive 48. I'm going to show you that here. So again, 1, -4 times 1 times a -12 is a positive 48. And then everything else I'm going to rewrite. I'm going to rewrite the divisor bar. 2 times 1, I just rewrite that. The radical, plus and minus, the -1, the negative. I just rewrite everything. And I'm going to take it step by step. All right, so I have parentheses, which is considered the radical. I have to simplify that first. So +1 plus a 48 is 49, right? And so everything else I'm going to rewrite. Everything else I'm just going to rewrite. I'm taking it step by step. What I did do, and I don't want you to miss this, was I multiplied 2 times 1, right? So 2 times 1 is 2. I just rewrote that to simplify that, since we are simplifying the radical. I want to simplify the denominator a little bit. And so now, in this step, you ask yourself, are there any parentheses? Yes, there are. There is the radical is considered a parenthesis. So again, I'm breaking all this down step by step. What's the square root of 49? 49 is a perfect square. It's 7 times 7. And so I'd like to show you that here. 7 times 7 is 49. And so everything else I'm just going to rewrite. Plus and minus the radical. I did skip something I wanted to show you here. Negative times a negative, that's an invisible -1, right? It is an invisible -1. And you're distributing a -1 times a -1 is a +1. I want to point that out here. And then I also multiplied the 2 times the 1 here. It's not going to change a thing. I just wanted to simplify those as I'm moving along. And again, the square root of 49 is a perfect square, 7 times 7. And everything else I'm rewriting. Everything else I'm rewriting. So to simplify that, I can pull 1 7. I got a pair of 7s, and a square root means I can pull 1 7 out. And then everything else I'm just going to rewrite, right? Everything else I'm just going to rewrite. So I'm showing you that here. A pair of 7s, you can pull out one value. Don't forget, it's plus and minus. Don't lose that plus and minus. It's very important. I'll show you later in the second part of this video. And that 1 7, you have a pair. You can pull one value out if you have a perfect pair because it's a square root, right? You need 2 perfect pairs to pull out one value. 7 times there's an invisible 1 out here. 7 times whatever's out here. Usually it's an invisible 1, but sometimes it could be a 2, a 3, a 5, but here it's invisible 1. So 7 times 1 is 7. Remember, that's a plus and minus 7. So then I'm going to substitute the radical here for just 7. And I'm going to rewrite that like you see it here. Okay. Perfect pairs of 7s. I'm showing you briefly how to pull out 1 7. And you just write that 7 here. Rewrite the plus and minus here. That plus 1, you just rewrite it. And the 2, again, you're going to rewrite it. Now, in the second part of this video, I'm going to break it down a little further to show you what our two factors are and why that is going to be the answer to finding our zeros of a function. Hey, math is easy. Take it step by step.